Hello, everyone. I'll introduce myself in a sec. I just want to explain the image. That's Maggie, our Springer Spaniel. I think every good story starts with a Springer Spaniel. I'll explain more as we go along. But anyway, that's me, Chris Brown. I'm an OpenStack deployment engineer with OCF. And I'm sort of like a diabetic Willy Wonka. That's my sort of that's the best sort of description I can give. Mahesh, my colleague, says I'm like a deaf Beethoven, I think, is it, or something like that. Anyway, the idea is I'm a deployment engineer, so essentially what I get to do is sort of create clouds but never actually play with them or use them or put any workloads onto them. So, it's like Willy Wonka never getting to taste the sweets kind of thing. I fall into a sort of an interesting gap when I go to sort of summits because I'm not an operator, I'm not a developer, and I'm not sort of a user. So I sort of wander around, not sort of being able to talk to anyone. But I've been doing OpenStack for a couple of years, well, more than now, actually, it's about 2.5 years. And OCF is a high-performance computing systems integrator. So we put OpenStack on HPC systems and try and get them running nice and quick. I've been involved with OpenStack since about the Icehouse release. And very, very occasionally I land some sort of upstream patches, but not an awful lot. And I contribute to the RDO project. I'm a maintainer of the clustering as a service, Sendling clustering as a service packages within RDO. And I'm obviously not the rapper, the Chris Brown rapper, who everyone sort of thinks I am or something. And when IT sort of, when people fade and sort of stop, think it's really dull, IT at dinner parties, I keep Bs as well. Bs are actually more interesting to talk about than IT at dinner parties. So yeah, why should you listen to me and not go and see the Triple O talk or whatever? Fair enough. This talks about Tempest and a bit of Rally as well. Tempest basically applies to pretty much, I think, everyone who's running OpenStack. So, hopefully you can get something from this talk today. I'd like to think. It basically applies to everyone, so developers, operators, engineers, users, whatever. Public cloud users use it an awful lot, who can use it an awful lot. You can uncover problems early before certainly if you're putting things into deployment, and this is what we found, is that you can find out, okay, before this thing actually goes into production, I've sort of discovered that this isn't doing some specific thing that it should be doing. Now, normally you'd find that out through a bunch of tests that you would run yourself, but you could sort of go, okay, let's spin up a VM, let's attach a volume to it, let's do a bit of work on it. But it's far easier to actually run some tests that somebody's actually automated for those specific tasks than trying to do all those tasks yourself. So automation and coverage. You're not going to be able to, with the best will in the world, even if you're the best engineer around, you're not going to be able to write 1,000 tests that cover every single aspect of the cloud that you've just purchased, or deployed yourself. And you can also use it for testing things like changes between upgrades. So you want to know that the thing that you've done now, is the change that you've made, has it made any fundamental changes to the cloud that you're running? So say, for example, if you switch from PKR to Fernet tokens or something like that, do you want to know that, okay, is everything still working or is it all sort of died? As a Ron Seal man, you want to know that, does it do exactly what it says on the tin? So the fundamentally OpenStack, cloud, if you've got an OpenStack cloud, it's not a cheap prospect. You'll have spent some serious amount of money on getting it there. So you want to know that it's doing exactly what you want it to do. Tempest is used within the Jenkins continuous integration system to actually test code changes before they're merged into the code base. So that's one of the areas that it's used. So obviously, if something sort of, if you just send a patch upstream, it's better if the developers go, okay, let's just check it to see if it's just garbage or actually if it works, and then we'll actually have a look at it. So it saves a lot of sort of developer time, prevents breaking changes. And actually, I think the key point in this, and this is my experience in sort of the 2.5 years that I've been doing it, is OpenStack code is really good. I think the number of issues with code that I've encountered in my experience, I can count on the fingers of one hand. Whenever we've encountered problems, it's always been down to networking generally or file system. Generally, it's the networking because we run parallel file systems which sit on top of the networking, and therefore, if you've got a shaky networking foundations, then the whole sort of house starts to fall apart. Yeah. When do you want to discover it? At which point in that process do you want to discover that it's not, you can't live migrate instances or whatever? There's Mr. Jenkins. And yeah, that's the question. Does it work as designed? And this can be applied to any OpenStack cloud. It's not just a sort of a typical RDO deployment or whatever. It's any cloud. That's the OpenStack. I went looking for every project's got a mascot. Nova's got a supernova. I don't know how you can have a supernova as a mascot. Sort of running onto the field dressed as a supernova. I can't say. Anyway, that's a bat. Apparently, it's a bat because it eats its own weight in bugs every day, or something. So that's the link to that's the OpenStack QA project. So it's got some design principles behind it. Tempest. One of them is it only touches the public APIs. So you don't need to have direct access to the database. You don't need to have access to the private admin APIs or anything like that. It just interacts with the OpenStack APIs. It should cover, basically all of certainly the core projects of OpenStack. It should clean up after itself. It doesn't. It's very messy, and I'll come on to that in a bit. And it should also test itself. So it should also have unit tests, so you know that actually, I don't know if it's like a who will guard the guards kind of thing, but it's like, okay, if Tempest is broken and I'm testing with a broken test suite, how do I know it's actually testing it? And you end up with, I don't know. You should be able to run it against any cloud, regardless of size. So it should be, if you've got 10 nodes or 10,000, you should be able to run it. You need to explicitly sort of define, okay, this is what I'm going to be testing. Rather than sort of taking a guess at, because you can sort of discover what services are being offered by a particular OpenStack cloud, but rather than guess at it, you want to say, right, this is actually what I'm going to test. And a really good thing about it is if you want to just do some like burn tests, something like that, or generate load very quickly, it's really good for that as well. So it's got generally three different types of tests. The API one is where the main sort of development work goes to. That's basically testing the OpenStack API. Do things function as you expect them to? The other interesting thing is that if you give it something wrong, if you give it something horrible, which you shouldn't be giving it, does it give the correct error code back? So it's not like just testing, can I boot an instance or can I get a floating IP or whatever, You've also got scenario tests, which people might be slightly more interested in. So these are like, okay, boot a VM, attach a volume, write some data to it, SH in, do all of this kind of stuff. So it's a whole sort of a recipe, if you will, and they're quite interesting. And then and the unit test for the self-validation as well. So those are the three. The scenario one tests for the interaction of services, different services. The API one will generally just sort of test a single type of service. So it tests various things like this. So you can say, and then as for sort of the garbage, so you say, right, can I have -1 instances? And hopefully you'd think, okay, OpenStack wouldn't just merrily carry on going, here's your -1 instance, crack on. You'd think, okay, it would sort of complain about that. And it does about 17, as I sort of last totaled it, a typical default Tempest test run does about 1,700 tests. So that's good. That's you've got to sort of think of other deployments of things that you've done and think, okay, is there anything really there that I can run 1,700 tests at it, come back sort of an hour later, and it's given me a full output of the result? It's, this is a really useful thing to have. I've certainly found it incredibly useful myself, because if you're running a sort of cloud yourself, or you're thinking of running a cloud yourself, or whatever, it's applicable in most use cases. That is, so getting installed. Rally is, in my opinion, the unsung hero of OpenStack projects, because I don't really hear anyone talking about it, but it is absolutely fantastic. Trying to get Tempest installed on its own, I spent sort of a day beating my head against a wall, and it didn't really sort of go anywhere. So Rally they sort of wrapped it nicely in an installer, in a one-line bash script, and it does everything for you, and it's fantastic. That's their mascot. It's an ermine, which is a stoat. It was supposed to have a rally jacket. Apparently, it doesn't have a rally jacket. I don't know why it's a rallying stoat. I can get the supernova thing. I don't get the rallying stoat, but it lost the jacket somewhere along the design process. I was looking for it. I found lots of pictures of jackets made from stoats, which is probably less appealing. But that's a slightly outdated link. I think there's been a big docs change, so now you should all use the docs.openstack.org thing. But that's the website, which will give you lots of information about how to get started using Rally. The release versioning on Tempest is a little bit weird, so it just basically uses the master branch. And you can store the data. One of the really good things is you can store it'll by default it'll store it in like a local SQL-like database, but you can also store it in MySQL or Postgres, which I think we still support in OpenStack. I don't know. I think there's some position statement or something coming out. And the developers are brilliant. The developers have always been really helpful with me whenever I need to go and have a chat with them. This is a slide of what Rally will actually do for you. I don't know. Deploy the top one I sort of queried a little bit because I've never used it to actually deploy a cloud, but certainly the middle two, verifying and benchmarking, are the ones where it really sort of excels. And I'd recommend sort of both those use cases. The reports are sort of pretty, but really that's the verifying and the benchmarking are the really interesting bits that I recommend you look at. That is pretty much it. Getting it installed. That just sort of that curl thing. You just run that, and then you source your credentials from your RC file, and then it's literally just a case of saying, okay. So if you want to do the verification element of it, the Tempest bit of it, it's just installing the verification element, generating a config, which it'll auto guess most of it from the RC file that you fed it. You can show the config, and then you just start the verification run. It's simplicity itself. You can also do things like target it against multiple deployments. So if you're running like two different versions of, if you're doing like a blue-green deployment or something, and you can sort of run it against either. Or if you've got a proof of concept or a dev test environment and a production one, then you can run them against either. So it's incredibly useful. You can just sort of say, okay, here's what was working before, here's what wasn't, and it obviously stores the results, and then you can diff the results against previous runs and things like that. So, fantastic. This is just a section of like one of the config files. So what it does, obviously, is enable you to sort of say, okay, in this environment, we're not interested in supporting like live migrations. So they're just Boolean values. You flick that to false, and it's not going to run those tests for you. So that's again, this is all sort of pretty simple, trivial stuff. The reports get stored in, like I say, in a database. You diff them against previous runs, and they'll output to HTML, XML, JSON, things like that. Pretty standard again. So it gives you 5 types of result. My favorite, I think, is the unexpected success at the bottom. It's awesome. If we had an unexpected success every day, it'd be happy, wouldn't it? Happy days. Okay. These are the reports it produces. Nice and... I'm sorry, the writing's really small there, but essentially what it does is it produces this nice, pretty HTML report. You can sort of toggle your success skipped expected failure, things like that. And then you can actually drill down, particularly if you've got a failure, and then it'll actually sort of tell you this is the response from the failure, and then you can sort of, depending on the output, it'll give you a sort of an understandable result or not, or it'll hopefully give you a bit more information as to why that particular test failed. So yeah, they're good, very easily readable, very easy to understand. So yeah, a little bit of a sort of a sub-story here, and as a lesson to me on sort of knowing your tools, because I was doing my first OpenStack project, and we have this thing called acceptance testing, whereby the customers come to us and said, here's a ton of money, build me a cloud. Okay, I've done it. And they say, right, how do I know that it's actually working? So you agree on this thing called it's acceptance testing. You say, how do we know that what you've done actually works? So I said, well, I've heard about this thing called Tempest, so we'll just run that and I'm sure it'll be fine. So I was like, and then I went and saw that it ran about 1,700 tests and all the fun and games that came with that. Traditionally, because we're an HPC outfit, the HPC acceptance testing doesn't transfer terribly well to the cloud. Normally, people get very excited in HPC about Limpack runs and things like that. So, getting in the top 500 and all of this kind of stuff. That doesn't. Maybe one day we'll have like a Tempest top 500 or something like that, or I don't know. But yeah, but they don't transfer very well. It's more about performance, but also about functionality. So it was just a case of, right, let's run this Tempest suite and then just iterate through. So you've got failures, you've got okay, so 200 have failed. Why have they failed? Come back, so on and so forth. So I had an interesting conversation with my boss. Sorry for the speech bubbles looking like the 1990s here, but it sort of went like this. I said, hey, Arif, I've just completed some Tempest runs on so-and-so's cluster. He said, great, what were the results? I said, 1,400 passes, only 14 failures, not bad, eh? Typical boss response, what about the failures? No one's interested in success. So these were the failures. There was about 1,600 tests at the time. 200, it wasn't a bare metal or Hadoop deployment, so we skipped those. This took a significant amount of time to actually understanding the error and finding out what was causing the error. But essentially, one of them, because Tempest is sort of under constant development, one of them was actually just a bug in one of the tests. But then the other two were fairly sort of trivial. I think the Neutron DVR, well, we weren't using Neutron DVR, so, distributed virtual routing, so fair enough, that errored. And then the other two, I think that was because Spectrum Scale doesn't have an open source license, so I think that was a license sort of complaint that it came up in Tempest for some reason. I'm not sure why that's so basically, you run through those and you go, okay, these are your expected failures. The reason for the unexpected success is sort of, if I was to declare that those 10 Swift errors were, I would just say, I'm expecting those to fail. So you declare on the Tempest run that you're expecting it to fail, and then it actually succeeds. That's an unexpected success. And we did have a few of those, interestingly, where it was just sort of timing out on the API or whatever. But so that was so a few caveats with running Tempest. It is messy. They have introduced a sort of a cleanup tool which tries to sort of slightly more intelligently go through and just clean up the resources that have been produced during the Tempest run to actually sort of go, okay, let's pull some of this out. But actually, after a lot of the runs, I was sort of going through and pulling out users, images, tenants, floating IP, things like that it hadn't actually managed to sort of clean up correctly. So it does get a bit messy, leaves bits of itself all over the system. I don't think that's improved hugely. So that is just one sort of slight caveat there. Some of the tests just seem to fail. Like I mentioned, there was that one with the Swift error. It's just a case of just following that upstream. And the people on IRC in the OpenStack QA room were were really helpful. But the failures can be hard to debug. Here's one example. That means absolutely nothing. Well, it means very little to me. I think I get what it's trying to tell me. I think it's expecting nothing in the square brackets, but it got something. I don't know. It'll mean something to someone, but it didn't mean something to me. So those are the things that, that can be a problem. So we've tested the cloud. We basically know it's sort of functional. It's doing what you kind of expect it to do, assuming. What you next want to sort of discover really is how have the changes that you've made significantly improved or degraded performance, which is a potential product of sort of making any changes or upgrades to the cloud. If you sort of upgrade from a Kata to Pike or whatever, do you want to know if it's actually running faster or slower than the previous one? We can also use Rally for this, and this was actually Rally's original design definition. I think they just rolled the Tempest stuff in afterwards because they maybe thought it was a bit of a nightmare as well. Am I right on time? Okay, yeah, good. So the results get stored in the same database, and you get pretty reports out of that, and it means that you can test changes to that as well. So you can sort of say, okay, let's make this change, let's deploy it. What's that done? Roll it back, whatever. So again, very useful. That's just a simple sort of Nova boot from volume and delete. That's pretty much all it needs. There's plenty of examples of that on the Rally GitHub repository. And what it produces is sort of something like that. So that's the report you get. So it can be quite interesting. You've got sort of you're starting your, this was just one I ran yesterday. 10 instances of boot and delete, not particularly snappy because it's just the test kit, but it starts off at sort of 22 seconds to do a boot and delete, and then gets down to below sort of 14, which is obviously quite a bit better. You can sort of, and then you can configure things like service level agreement to say, right, it's got to be below this mark, and it'll tell you if that's passed or failed and things like that. So, so you can go off and test your clouds with Rally and find out how fast they're actually sort of running, and it's quite useful. And then sort of the differences, it'll tell you how much of that is idle time, how much of that is actually running the test, and things like that. What else we've got? So that was only doing two iterations at the same time, up to a maximum of 2. But obviously you change. I mean, you do 1,000, say, in a normal run. Tell you the errors, various things that it's been doing, and then so that's quite nice. It sort of breaks it down into the delete, the bit that's doing the delete, Cinder doing the create volume, Nova doing the boot. So you can tell that Cinder took 5 seconds to actually create the volume, Nova took 11 seconds to boot it, and then the deletion stage took 4 seconds. So, and then you can sort of play around with it and go, okay, let me change a few options, let me do this, do that, blah, 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 and has that actually improved the speed of it and things like that. So it's good for sort of, particularly if you're interested in, getting your servers up nice and quick, and if that's an important part of what you're doing. The upshot of it all is that, once you're happy with the cloud and it's good to go, is that Maggie gets her walk, and there you go, one happy spaniel. Good stuff. Any questions? I think we've got 3 minutes. Awesome. Thanks very much, folks.